Chemistry is all about changes. Trees grow and they may change color from an intense green color to a less green color, or from yellow to red. Grass grows and its color may change to light yellow due to changes in temperature. On the next picture, you can observe two nails. The first nail do not contain any brownish substance present on it known as rust, while the second nail contains some brownish substances present on it. On our next picture, you can observe a girl with black hair. But due to the use of some chemicals on her hair color may change to yellow. That is, her hair is now bleached. On our last picture, you will observe grape juice undergoing fermentation to obtain wine. These are just a few examples of chemical changes that affect each of us. In all the above examples, the nature and identity of the initial substance have somewhat changed. Whenever a chemical change occurs, we can say that a chemical reaction has taken place. Thus, a chemical change is a change in which one or more new substances are formed. It is also called a chemical reaction. Chemical reactions are the heart and soul of chemistry, and in this chapter we will discuss the fundamental ideas about chemical reactions. You may perhaps be wondering as to what is actually meant by a chemical reaction. How do we come to know that a chemical reaction has taken place? Let us perform some activities to find the answer to these questions. Activity 1. Clean a magnesium ribbon about 2 centimeters long by rubbing it with sandpaper. Hold it with a pair of tongs. Burn it using a Bunsen burner and collect the ash formed in a watch glass. While burning the magnesium ribbon, keep it as far as possible from your eyes. It will be better if you wear an eye protection. What do you observe? The magnesium ribbon burns with a dazzling white flame and changes into a powder. This powder is called magnesium oxide. It is formed due to the reaction between magnesium and oxygen present in air to give rise to the magnesium oxide powder. Activity 2. React calcium metal with water. You will notice that bubbles of hydrogen gas are formed in the pool. For our next activity, add a solution of sodium dichromate to a solution of lead nitrate a yellow solid is formed. Activity 4. Add colorless hydrogen chloride to a wet solution of cobalt to nitrate. The solution turns blue. This is a sign that a chemical reaction has taken place. Our last activity is activity 5. Take a few zinc granules and place it in a conical flask. Add dilute sulfuric acid to this. You will obtain something like this. Do you observe anything happening around the zinc granules? Touch the conical flask. Is there any change in temperature? On addition of the sulfuric acid to the zinc granules, hydrogen gas is formed with a subsequent increase in temperature. From the above 5 activities, we can see that any of the following observations help us to determine whether a chemical reaction has taken place. That is, a change in state will be an indication that a chemical reaction has taken place. For example, the case of hydrogen chloride reacting with zinc to obtain hydrogen gas and zinc chloride. A change in color is another indication that a chemical reaction has taken place. The color of magnesium changes from white to a white powder. The evolution of a gas would also indicate that a chemical reaction has taken place. Hydrogen gas is evolved in the reaction between hydrogen chloride and zinc granules. Finally, a change in temperature. The temperature in the conical flask increases as the hydrogen chloride reacts with zinc granules. Even the magnesium ribbon becomes warmer, that is, its temperature increases as it is being heated using a Bunsen burner. As we observe the changes around us, we can see that there is a variety of chemical reactions taking place around us. We will study about the various types of chemical reactions and their symbolic representation as we proceed. Types of chemical reactions. We have learned that during a chemical reaction, atoms of one element do not change into those of another element, nor do atoms disappear from the mixture or appear from elsewhere. Actually, chemical reactions involve the breaking and making of bonds between atoms to produce new substances. We will begin with combination reaction. Take a small amount of calcium oxide or quicklime and place it in a beaker. Slowly add water to this. After some time, touch the beaker as shown in the figure. Do you feel any change in temperature? Calcium oxide reacts vigorously with water to produce calcium hydroxide or slackline, releasing a large amount of heat. In this reaction, calcium oxide and water combine to form a single product, which is calcium hydroxide. Such a reaction in which a single product is formed from two or more reactants is known as a combination reaction. Let us proceed with some more examples of combination reactions. 1. Burning of coal. Carbon reacts with oxygen present in air to obtain a single product known as carbon dioxide. Our next example will be the formation of water from hydrogen and oxygen. Hydrogen gas reacts with oxygen to obtain a single product known as water. Therefore, we can say that when two or more substances, that is, elements or compounds, combine to form a single product, the reactions are called combination reactions. Note, when we observe that a large amount of heat is evolved or released along with the formation of products, the reaction is called exothermic chemical reaction. Example of such a reaction would be the burning of natural gas. Methane burns in air, that is oxygen present in air, to obtain carbon dioxide and water. The next type of reaction we are going to see is decomposition reaction. Take about 2 grams of ferrous sulfate crystals and place it in a dry boiling tube. Note the color of the ferrous sulfate crystals. Heat the boiling tube over the flame of the Bunsen burner as shown in the figure. Observe the color change of the crystals after heating. Have you noticed that the green color of the ferrous sulfate has changed? You can also smell the characteristic odor of burning sulfur by wafting gas gently towards your nose. The ferrous sulfate, in the presence of heat, decomposes to ferric oxide, sulfur dioxide, and sulfur trioxide. In this reaction, you can observe that a single reactant, that is ferrous sulfate, breaks down to give simpler products. This is a decomposition reaction. Ferrous sulfate crystals loses water when heated, and the color of the crystal changes. It then decomposes to ferric oxide, sulfur dioxide, and sulfur trioxide. Let us perform another decomposition reaction. Take about 2 grams of silver chloride and place it in a china dish. What is its color? Place this china dish in sunlight for some time. Observe the color of the silver chloride after some time. You will see that the white silver chloride turns gray in the presence of sunlight. This is due to the decomposition of silver chloride into silver and chlorine by light. That is, silver chloride in the presence of sunlight decomposes to silver and chlorine respectively. Note, decomposition reaction requires energy, either in the form of heat, light, or electricity for breaking down the reactants. Reaction in which energy is absorbed are known as endothermic reactions. The next type of reaction we are going to see is displacement reaction. Take 3 iron nails and clean them by rubbing with sandpaper. Take 2 test tubes marked as A and B. In each test tube, place about 10 ml of copper sulfate solution. The 2 iron nails with a thread are being immersed carefully in copper sulfate solution in test tube B for about 20 minutes. Keep 1 iron nail aside for comparison. After 20 minutes, take out the iron nails from the copper sulfate solution. Compare the intensity of the blue color of copper sulfate solution in test tube A and B. Also compare the color of the iron nail dipped in the copper sulfate solution with the one kept aside. Why does the iron nail become brownish in color and the blue color of the copper sulfate solution fade? The following chemical reaction takes place. Iron present in the copper sulfate solution displaces copper from its solution to obtain iron sulfate plus copper. In this reaction, Iron has displaced or removed another element, that is copper, from the copper sulfate solution. This reaction is known as displacement reaction. Other displacement reactions are zinc reacting with copper sulfate to obtain zinc sulfate and copper. Lead also reacts with copper chloride to obtain lead chloride and copper. In the above reactions, zinc and lead are more reactive elements than copper. That is, copper is less reactive than zinc and lead, and thus they displace copper from its compounds. We'll proceed with double displacement reactions. Take about 3 ml of sodium sulfate solution and place it in a test tube. In another test tube, take about 3 ml of barium chloride solution. Mix the two solutions. What do you observe? You will observe that a white substance which is insoluble in water is formed. This insoluble substance formed is known as a precipitate. Any reaction that produces a precipitate can be called a precipitation reaction. That is, when sodium sulfate reacts with barium chloride to produce barium sulfate and sodium chloride, a white precipitate is formed known as barium sulfate. What causes this? This white precipitate is formed by the reaction of sulfate ions and barium ion. The other product formed is sodium chloride, which remains in solution. Such reaction in which there is an exchange of ions between the reactants are called double displacement reactions. The last type of reaction we are going to treat is oxidation and reduction. Heat a china dish containing about 1 gram of copper powder. What do you observe? The copper powder becomes coated with black copper 2 oxide. Why has this black substance formed? This is because oxygen is added to copper and copper 2 oxide is formed. That is, copper in the presence of oxygen in air. When heated, you obtain copper 2 oxide. If hydrogen gas is passed over this heated material, that is copper oxide, the black coating on the surface turns brown as the reverse reaction takes place and copper is obtained. That is, copper 2 oxide reacting with hydrogen gas, you obtain copper and water. If a substance gains oxygen, During a reaction, it is said to be oxidized, while if a substance loses oxygen during a reaction, it is said to be reduced. During this reaction, the copper to oxide is losing oxygen and is being reduced, while the hydrogen is gaining oxygen and it is being oxidized. In other words, one reactant gets reduced while the other gets oxidized. Such reactions are called oxidation-reduction reactions or redox reactions. That is, looking at this picture, you notice that copper oxide is undergoing oxidation to obtain copper and water. The hydrogen has been oxidized by gaining oxygen, while the copper oxide has been reduced by losing oxygen. Now, can you recall the first activity which we did, where magnesium ribbon burned with a dazzling flame in air and changed into a white substance known as magnesium oxide? Is the magnesium being oxidized or reduced in this reaction? Make sure you answer this question before the next lesson. Thanks for your kind attention.